Hello everyone, this is Poornima Deepthi working as an assistant professor in the Department of ECE at MLR Institute of Technology. Today I'll be going to explain how to interface a to D converter with 8086 microprocessor, as this video is a part of series microprocessors and microcontrollers. So coming to the overview of today's topic, what are analog to digital converters, why we are using these converters for microprocessor, and what is the ADC analog to digital converter 0808, what is the pin configuration, and what is the block diagram of ADC 0808, and how to interface this ADC with 8086 microprocessor. So coming to the analog to digital converters, why we need to convert analog signal to digital signal? So because here we are using 8086 microprocessor, or this microprocessor or the CPUs are always deals the digital data or the data which is in the digital format. So normally the data which we are using here in natural data form is the analog form. So to operate microcontrollers, to give the data to the microprocessors, we need to give digital data. So that's why here microprocessor need to get the data, digital data from the A to D converters. So A to D converters is used as an input to the microprocessor. This is the thing. But here we can't directly connect, as this is the input device, we can't directly connect input output peripherals to the microprocessors. We need to interface the microprocessor with input output devices by only using 8255 PPA, programmable peripheral interface. Okay, and these A to D converters are used to treated as input devices. Why? Because it is getting the data, it is giving the digital data to as input to the microprocessors. So how these A to D converters work? So basically, if A to D converters need to start conversion, the microprocessor will give the input that start the conversion signal, start the conversion SOC signal to the A to D converters. Then the conversion will start, and after done with the conversion, the A to D converters need to send a signal of end of conversion. I have already done the conversion, so you can take the output at the ADC buffer. So end of conversion, while microprocessor receives the end of conversion signal, then it can able to get the output from the buffer of ADC. This task of issuing SOC and getting EOC and receiving the output is part of the processor by using only 8255 PPA, programmable peripheral interface. So the time taken to start the SOC signal and receiving the EOC signal. So the time between this SOC and EOC signal is nothing but the conversion delay, which is the time taken for the ADC to convert the given analog signal to the digital signal. So any ADC like 0808 or 0809, like this, any ADC, A to D converters we can employ, but the algorithm it should follow any ADC is, first, it need to ensure the given analog input is stable. And the second thing, issuing of SOC signal from the processor. And third thing is issuing the end of conversion signal by the processor and getting the output, reading the output of the ADC by the processor. These are the 4 algorithmic steps you need to follow while interfacing ADC with any devices like a processor or controller. So here we have been using to interface a ADC to 8086 microprocessor. This is the block diagram of 0808 ADC, A to D converter. As ADC is a 0808 is a 8-bit converter. So it can convert 8 analog inputs, but at a time it can only convert each input. So out of to convert these 8 analog inputs, they've been using 8-channel analog multiplexer. So what is a multiplexer? n number of inputs, you will get one number of outputs. So in ADC, they've been using this 8-channel multiplexer. So this is a successive approximation process this ADC is using. It is very beneficial apart from the other ADCs. So here this is the input 1, input 1, input 2, input 3, input 4, input 5, input 6, input 7, input 8. So these 8 inputs can be applied to the multiplexer. Out of 8 inputs, it can only take one input and it can decode it into the digital form. So to select which input need to be selected will depends upon the address lines, or you can say that control line. 0, 0, 0 will fetch input 1. 0, 0, 1 will fetch second input. 0, 1, 0 will fetch third input. 0, 1, 1. 1, 0, 0 input 4. 1, 0, 1 input 5. 1, 1, 0 input 6. And 1, 1, 1 will fetch input 7. These are the control or address lines which fetch which input need to be converted. So, okay, if I want to convert input 2, I will take input 2. So, if I want to convert this input 2 into the digital data. So, now multiplexer will consider this input 2 and send it to the control and training unit, where here the clock will be having, and according to the clock, it will have the control signal SOC, start of conversion. So, it will basically we will get the start of conversion from the processor. So, once we have received the start of conversion, then this particular unit will convert the corresponding analog signal to the digital signal. And once it have done the conversion, it will send the another control signal EOC, end of conversion signal, to the microprocessor. So that microprocessor will able to know that yes, conversion have been done and I can get the information from digital data from this output latch. So these are the registers and we will be using in the ADC. So out of this we will get the digital data. Here the digital data is also 8-bit data. So this is the output latch or output buffer of a ADC 0808. So now coming to the pin diagram. So how many analog inputs we have been given? Out of 8 analog inputs, 1, 2, 3, 4, 5, and here these three are the inputs, and these DB72 digital bits 0 to 7, here bit 3 and bit 1. These are the output bits, output digital data. Send and output control pin will be there, clock, power supply VCC, reference voltage value will be there, address latch enable will be there. These are the address pins which will select which input need to be get from the multiplexer. So next, these are SOC, start of conversion pin, end of conversion pin. Now coming to the interfacing of 0808 ADC with 8086 microprocessor. So there is a one problem, like interface ADC 0808 with 8086 using 8255 ports. Use port A as transferring digital data. So it is been using as a output port of ADC to the CPU, and the port C is for control signals. So these are the control signals. Port C is using control signals. What are the control signals in ADC? Analog to digital converter, SOC, and start of conversion and end of conversion. These two pins. So you can select port C for control signals, means port C upper is used for one thing and port C lower is used for one thing. And here they have been selected as a input 2. So, okay. Now, first of all, if we want to interface any input-output device to microprocessor, we need to have 8255 PPI. So, to work 8255 PPI, we need to write the CWR register, control word register. Here is the control word register. D7 is used for input-output or BSR mode. As this is the input device, so we have been taking it as a one input-output mode. and these two are used for selection of mode A, which mode of port A. So here they didn't mention, so basically we have been using only simple input output mode, which is nothing but mode 0. So that's why I've been taking 0 0. Now D4, this is the port A bit, whether it is acting as an input or output. Actually ADC is considered as an input to the microprocessor, that's why we are taking 1 over here, input. So D3 is the port C upper, right? Port C upper. Here port C upper is used to select the SOC pin, start of conversion. So it is a input from the processor. So we have been taking it as a 1. D2 is the port B mode. Basically we are not using that, so basically we will keeping it as a output port. We have to transfer the data or the microprocessor. And D0 using to get the end of conversion signal. So 2 signals. Port C is used to take the control signal. So we are having 2 control signals, SOC and POC. Sorry, SOC and EOC. So at start of conversion and end of conversion. Here port C upper is used as a start of conversion pin, and port C lower is used for the end of conversion pin. So here what we are getting, it is 9 and here 8. So that's why we need to load 98H to interface a ADC to 8086 microprocessor. So here first we are loading 98H, and next AL is moved with 02 because port B. What is port B? We are taking input in port B, right? So what is the input we need to convert? Input 2. They have mentioned input 2. That's why we are taking 0, 2. Next, here, so we need to send the signal, analog signal, to start the conversion or end the conversion. Here, the analog signal what we are taking from port C, 0, 0. So first 0, 0, and next it is moved to 1, 0, 0, 0, 1, and again it is moved to 0, 0. So this is the signal we are sending to the ADC to convert. So yes, we have given the signal, but we need to start the conversion process. So how to start the conversion process? Here port C, we are starting with the port C. Here we are giving port C. If we are receiving the SOC signal, rotate R. So if we are port C, lower is used for EOC, port A, port C upper is used for SOC. So if you are saying SOC signal, so if it is receiving the data, if it is receiving the EOC signal, then jump if carry is wait, jump over. Again it will jump to the wait. So unless it is receiving the EOC signal, the condition will be moved here itself. And if we are getting the EOC signal, then only it will get to halt stage. So this will get converted, right? This is the program to interface ADC with 8086 microprocessor, and this is the interfacing circuit. Here 8255, here it will be the microprocessor. So this is the clock. Analog input voltage, here we have been applying input to this 0808 will convert it into the first, this microprocessor will send the information to 8255 to send the SOC signal to the ADC. Then only this ADC will start conversion the required input. Here the required input is input 2. So it will start converting this. If it done with the conversion, then it will send back the EOC signal to the 8255. And if processor is getting the EOC signal, then the conversion is now done. It will take the output from the output 0 to 07. So this is the interfacing circuit of 0808 ADC with 8086 microprocessor. So until now we have discussed what is the ADC and 0808 ADC and how ADC is interfaced with microprocessor and how to write a program to interface a ADC with 8086 microprocessor. Thank you.